Hello everyone, welcome to Universal Group of Institutions. Today we will talk about continental drift theory, especially given by the Alfred Wegener. So we will go into detail. Let's jump right in. In earlier videos, we have talked about the Earth's crust formation and the interiors. Go check that video. So students, in early scientists, when we were not having that much technology, early scientists used to believe that Earth contracted as it cooled, forming wrinkles, and those wrinkles became mountains. Early theories. So now it was early theory. Now the theory is that our Earth mountains are formed due to the plate tectonics, not the wrinkle formations. Okay, so how exactly these mountain formed? So this particular continental drift theory talks about how there was a one large continent. Now it has been changed into the 7 continents as we see of today. Okay, so our concerned person, like he was the Alfred Wegener, he was from the Germany, he was geophysicist. He presented his hypothesis called continental drift in 1912, and in 1915 he published Origin of Continents and Oceans. Okay, so in this particular article his theory was present, continental drift theory. So what exactly happened? Let's go to the past. Alfred Wegener noticed that the continental resemble jigsaw puzzle pieces. Actually, he was in Atlantic Ocean and he was doing some exploration, some research purpose. So he opened the map. Okay, and in this map he saw South America and Africa, and in his mind it came that the coastline of South America is much like it is matching with the Africa, and what he did, he combined these two like this. Okay, now can you see this? South America is totally fitting into the Africa. That's what his first theory was, that he thought that earlier continents were one, then they got different apart from each other. Okay, so this particular continental this puzzling is called jigsaw puzzle. So according to Wegener, he proposed the theory that continents were once the part of one single landmass or supercontinent called Pangea. So can you see this supercontinent? This supercontinent is called Pangea. Eurasia, North America, South America, Africa, India, Antarctica, Australia, all were one, and after that it got separated. As we see today, North America, South America, Africa, Eurasia, and Antarctica here. Okay, so according to Wegener, Pangea broke up millions of years ago and continents began to drift and reach the present day position. Then he talked about that how many years old. So according to our geological time scale, 250 million years ago we call it Permian age, Triassic, Jurassic, and Cretaceous, and this is the present day. So basically in Permian age there was one Pangea, big Pangea was there. In Triassic age this Pangea started to break, and it started to break into Laurasia, into Gondwana. So basically students, the part that is drifted into north hemisphere or north direction, that is called Laurasia, and there is one more word for it, Angara land. Remember that. So Angara land and Laurasia is that continental mass that drifted into north, and the continent that remained in southern hemisphere is Gondwana land. Okay, and this is our Tethys Sea. So can you see this? Basically the earlier it was joined, now it is getting separated, so it became Tethys Sea. Okay, after that Jurassic period came, the dinosaur was here in the Jurassic period around 145 million years ago. So this world map is of Jurassic period. Then came our Cretaceous. So still, as you can see that India is not the part of Angara land, still in Cretaceous period. After before 65 million years ago, India was not the part of Angara land. It was in the middle. This is Gondwana land, this is Angara land. It was in the middle section. Okay, and after millions of years, India got directly, Indian plate hit to Eurasian plate, and today's Himalayas were formed like this. So because of continental drift, oceans and continents were formed actually. Okay, today's 7 continents and 5 oceans are these are the result of the continental drift only. Okay, yeah. After that, so basically Pangea is the larger one, large continental landmass. So can you tell me in the comment box, what is this big ocean called? This big ocean is called Panthalassa. Okay, got it? Yeah. Chalo. Now students, Wegener told all these things, but you know people, right? They need evidence. So everybody demanded evidence from the Alfred Wegener कि just because two things are combining doesn't mean that continents were one. You have to tell us that evidence apart from that jigsaw fit. Okay, so first of all, you should subscribe the channel, keep the notification bell on so that you can get such videos at earliest. Okay, yeah. So basically Alfred gave 5 evidences. First was jigsaw fit, second was stratigraphic evidence, third is fossil evidences, fourth is placer, and fifth is Tillite evidence. First is jigsaw fit. He told ki see, you can just take world map and you can scissor it, like you can cut the world map into 2 parts, and he was right in some way also. So basically he was proving the theory and he was right. That's why we are reading Alfred Wegener even today. His theory is relevant. Yes, some evidences, or we can say like plate tectonics, geomagnetism, he didn't tell about all these things, but it was his first attempt. Anybody was doing the first attempt to prove that continents were they were earlier one, not the different as we see today 7. So first one is jigsaw fit, second one is stratigraphic. Stratigraphic means matching rocks. Strati means rocks. So he told that this is our North America and this is our Europe. Now he told that Appalachian mountains and Caledonian mountains, these rocks are similar rocks in composition, in age, and the mountains are similar. So he told that how is it possible if these two parts was not connected? How come that age and composition of rocks are same? That was his second evidence. Third one was that second more he gave, like this is regarding the Europe. Then he went to Africa and South America. This is our South America. This is our Africa continent. He told that Brazil's coast and Western Africa, this one, Ivory and Ghana coast, even their rocks are similar. These are similar. So this was his second proof. You see, earlier the continent was one. Gondwana coal deposit, third example, that we can see that in Antarctica, India, Africa and South America, in these continents, Gondwana coal deposits are found. There are 2 types of coal deposits. First is Gondwana coal deposits and second is tertiary coal deposits. In our India, we get the Gondwana coal deposits in Chota Nagpur Plateau region. Chota Nagpur Plateau region. Okay? So this is our second stratigraphic evidences. Then the third is radiometric dating, like how you will calculate that how much older the rocks are. So radiometric dating, what is the radiometric dating? Techniques used to determine the age of materials such as rocks or fossils by measuring the decay of radioactive elements within them. And as you can see the rocks here, and there is we are doing the radiometric dating. So we will, with the help of instruments, we will calculate the radioactive elements within them, that how they got decayed and how much it is older. So this particular methodology is called as radiometric dating. Remember that, it is important for your UPSC perspective. Okay. Now third evidence he gave was fossil evidences. So as you can see in the photo, in the diagram, that these are the real fossils. The first one is Cygnognathus. This was the first one. So we have found the fossil remains of Cygnognathus. It is a land reptile approximately 3 meters long. As you can see, it is the head only, it's so big. So this Cygnognathus fossil have been found on South America as well as Africa. Okay, South America as well as Africa. Now Alfred Wegener is saying, how come this reptile who cannot swim is found in both Africa and America? Logic point. Second fossil he gave evidence was Mesosaurus. So this is our Mesosaurus. So we have found this fossil fuel evidence again in South America and Africa. So Alfred Wegener is again saying, how is it possible that again this fossil remains of freshwater reptile cannot swim in the water, it has to be on the land itself. So how come this particular animal fossil has been found in both Africa and South America? So he is telling South America and Africa were the one part earlier, that's why we have found this Mesosaurus on the both continents. The third evidence he gave was our Listosaurus. An interesting fact about Listosaurus was that Listosaurus fossil fuel has been found in India also. So Listosaurus, Africa, India and Antarctica. These three are the continents where Listosaurus fossils have been found. Again, it was the same reptile. And the fourth evidence, like till now, all were reptiles. Now, this is our fern, F-E-R-N, fern. Okay, ferns. So these are the leaves, or we can say a part of the plants that have been found inside the rocks safe, and we have done the radiometric dating. This Glossopteris, this is the name of the fern that has been found in South America, Africa, Antarctic, India and Australia, all the continents. Again, it proved the theory of continental drift by Alfred Wegener. Okay, and the fourth evidence is placer deposits. Placer deposits are the concentration of valuable minerals, typically gold, platinum, tin, diamonds and other heavy minerals that have been naturally concentrated by the water processes. So what exactly are placer deposits, students? Check out these ones. Suppose that we are having the gold, and you know gold is found on the rocks in the impure form. So what have happened, students, that we have found the gold deposits in the Brazil. Try to understand. We have found the gold rock in Brazil, but we have found the deposits, means the gold dust in the Ivory Coast. And wherever we are finding the gold dust in Ivory Coast, Ghana coast, we don't have any rocks there. So rocks is present in Brazil and the gold dust is present in the Ivory Coast, that is in Africa, different continents. How is it possible? That is our placer deposits, fourth evidence. And the fifth evidence was Tillite deposits. So Tillites are the sedimentary rocks from which glacier deposits are. These are the sedimentary rocks from the glacier deposits. When the glaciers are there, and when they are moving, they are getting eroded. They are getting the mountains eroded. So such type of formation you will find in all the continents. That is also so these are the 5 evidence according to Alfred Wegener, and these Tillite deposits have been found in all the 5 continents. Okay, so these are the summary: jigsaw fit, stratigraphic evidence, fossil evidence, placer deposits and Tillite deposits. So if you like this video, do subscribe the channel, keep the notification bell icon on, and please share this video to everybody who want to know how the continents drifted. Okay, and if anybody is preparing for GS2, geography, optionals or whatever the competitive examination where geography is important, you should recommend this particular video or channel to the concerned people. Thank you so much and see you in the next one.